Hello everyone. In today's class, we will see the new topic, that is effect of temperature on thrust. What is that topic? Effect of temperature on thrust. Effect of temperature on thrust, or I am writing here upthrust. What is the topic? Effect of temperature on upthrust. So what is this upthrust, and when any substance is immersed in a liquid, what happens? Let's see. Okay. So first, when when an object is immersed in a liquid, there is upward force acting, that is called buoyant force. There is upward force acting on body called buoyant force. Buoyant force. Now see here, suppose we have taken one container like this. The container, and in this container we have taken liquid of density rho, and suppose now I have immersed an object here like this. Then on this object, how many forces are acting? In the upward direction you are having buoyant force, and downward direction there is its weight. No? Now this buoyant force is what? Buoyant force is what? A vertical upward force which exerted by the liquid. Yes. So here upthrust is upward force in this case. See here, this is a buoyant force. Can I write like this? Fb is nothing but upthrust. What is this T means? Upthrust. So we know Fb is given by rho of liquid into volume of object into acceleration due to gravity. This is a buoyant force formula which you might have learned in lower classes, that is in Archimedes principle. Yes or not? Buoyant force. Now therefore, as we know, this buoyant force is upthrust. So can I write here as a T is equal to rho L BOG? That is what? Upthrust is nothing but density of liquid into volume of object into acceleration due to gravity. Is that clear? What we have seen? First we have seen when an object is immersed in a liquid, then there will be one force which is acting in upward direction, that is called buoyant force. And upthrust is what? Nothing but upward force. Therefore, in this case, buoyant force is what here? Thrust. Now, this buoyant force, we know what is that? Rho L into volume of object into gravity. So, therefore, thrust will become rho L into, rho L is what? Here, rho L is what? Density of liquid. Density of liquid. And V naught is what? Volume of object. Volume of object. And G is what? Acceleration due to gravity. You know it. Acceleration due to gravity. So this is what your buoyant force, and this is nothing but thrust. Now, due to the temperature change, what will happen, or what is the effect on this thrust? We are going to learn in this topic. Okay, so let's see. First of all, pause the video, note down these things slowly. If you have doubt, ask me. Yes, so let's go ahead. Now, here I got formula, that is thrust is equal to density of liquid into volume of object into acceleration due to gravity. This is what I got for thrust formula. Now, suppose this is initial thrust when temperature is not changed. What we did? Temperature is not changed. Now, when temperature is changed, what happens? When temperature changed, when temperature change, what will happen? Density of liquid will change. Yes or not? What will happen here? Density of liquid will change. Is that clear? Yes. Density of liquid will also change. Volume of object will also change. So here, when temperature changed, density of liquid and volume of object changes. Volume of object. Yes, we have learned this before. Effect of temperature on volume. Already we know effect of temperature on density of liquid or anything, that also we have learned. So if temperature change is delta theta. Temperature change is delta theta degrees Celsius. If what I am writing here, if whatever we have assumed here, that is temperature change if temperature change is delta theta degree Celsius, then here rho L dash is equal to, we know this, we have learned this. So what is that? Rho L divided by 1 plus gamma L into delta theta. This expression we have learned before. Yes or not? dt is equal to d0 by 1 plus gamma L delta theta. Here I have assumed rho L dash after increasing temperature, and rho L is initial density of that liquid. So this formula we know. Then this is the density, and V dash is equal to what here? V dash is equal to what? V naught into 1 plus gamma of object into delta theta. This also we know. This is what? For volume. So after changing the temperature, the thrust is what? T dash. T dash is equal to what? Rho L dash P dash into G. Isn't it right? Now we are having this as equation 1 before change in temperature. This is equation number 2 after changing the temperature. Is that clear? What we did? When temperature change, density of liquid and volume of object changes. That's why if temperature changes delta theta degree Celsius, then whatever we got these two equations, rho L dash and V dash, and this is what thrust after changing the temperature. So from equation 1 and 2, see here, from equation 1 and 2, what we are getting? If I am dividing these two, T dash by T, that is thrust, is equal to rho L dash V dash G divided by rho L into V naught into G. Yes or no? What we got? Rho L dash V dash G divided by rho L V naught G. This is equal to, let's substitute the value now. Rho L dash का value क्या है? Let's substitute here. Wait, I will substitute in the next step. Is it okay? So see here, rho L dash value we know. Substitute here rho L by 1 plus gamma L delta theta. This finished rho dash. V dash is what? Here it is. So V naught into 1 plus gamma of object into delta theta into G divided by this one as it is, that is rho L P naught into G. This G will get cancelled with this G. This V naught will get cancelled with this V naught, and this rho L will get cancelled with this rho L. So what is left now? We can see here, this is the numerator, 1 plus gamma of object into delta theta divided by 1 plus nothing. What is here? 1 plus gamma L. Yes or no? 1 plus gamma L into delta. This is what we got. So here final formula is what now? Thrust at temperature delta theta divided by initial thrust is equal to 1 plus gamma of object into delta theta divided by 1 plus gamma L into delta theta. This is what we got, the relation between two thrusts, that is thrust at temperature delta theta and thrust initial whatever the initial temperature was. Means this is just the relation when change in temperature is delta theta, isn't it right? Now pause the video, note down this. If you have doubt in any step, ask. Okay, so let's move ahead. Now see here, again I am drawing another diagram. What is effect on apparent weight? What is effect on apparent weight? Yes. So let me draw first diagram. How will be the apparent weight when an object is immersed in a liquid? I am drawing little small diagram. No need little, what can I say, big one. You see here, this is what your object which you have immersed in a liquid, and now we are having two forces. Upward is buoyant force, downward is mg, and apparent weight means what? Here only you will get, yes or not? Or I am writing like this: W apparent is equal to mg minus buoyant force. Why? Because actual weight is mg. Some force which liquid will exert on that object, it will be in opposite direction, that is in upward direction. So that's why when we are inside a liquid, we will feel little, what you can say, we will feel less weight, right or wrong? That is what due to buoyant force. And in this case, apparent weight is what? Mg minus Fv. Now, see here, can I write like this now? W apparent is equal to mg is what here? Actual weight. Mg is what? Actual weight. Minus this Fb is nothing but what? Thrust. Yes or no? Apparent weight is what? Actual weight minus thrust. That is nothing but buoyant force. So we know gamma of object is less than gamma of liquid. Agree? Why? Because liquid expands more as compared with solid object. Agree? So when gamma, wait, let me write this thrust formula also so that you will understand more. You can see last formula which we got, T dash by T is equal to 1 plus gamma of object into delta theta divided by 1 plus gamma of L into delta theta. This was what our formula is. Yes. So from this formula, what we have to conclude here, gamma of object is less than gamma of liquid. That is, liquid expands more as compared with solid. That's why coefficient of liquid expansion is greater as compared with this. So as this is a more, so what you will get from this, you can see here, therefore T dash is what? Less as compared with T. Understand? T dash will be less as compared with T. So therefore, what happens here? Conclusion is what? See here. What is conclusion? With rise in temperature, with rise in temperature, thrust decreases thrust decreases and apparent weight of body increases, and apparent weight of body increases. Sir, one more time, listen here. Now you concentrate on this formula. You see here this formula. W apparent is equal to actual weight minus thrust, right? Now if this factor will be more, if this thrust factor will be more, we are going to subtract from actual weight. So if this is more, this will become less. If this will be less, this will become more. Understand? So if thrust decreasing means this value will become less. Thrust is decreasing means what? This value is becoming less. When this value is becoming less, this W apparent will be more, and therefore with increase in temperature, thrust decreases and therefore apparent weight of body increases with increase in temperature. याद रखो. So therefore when temperature increased, apparent weight increases and thrust decreases. Understood? Note down this part. Yes. Okay. Pause the video and note down this. Next. Now, one note point I want to give because it will be very helpful for you in the problem solving. This is whatever we have learned, that is common formula. Note point: if D1, D2 are densities of liquid at T1 and T2 degree Celsius, and V1, V2 are volumes of object or solid, you can say, at T1 and T2 degrees Celsius. Then thrust at T1 degrees Celsius, thrust at T1 degrees Celsius is equal to T1, I am writing, T1 is equal to V1 D1 G. And next one, thrust at T2 degrees Celsius is equal to T2, which is equal to P2 D2 into G. Now here, if I want to take the ratio of these two, then what I am getting? T1 by T2 is equal to P1 D1 G divided by P2 D2 G. This G will get cancelled. And I am getting formula T1 by T2 is equal to P1 D1 divided by P2. Now this V1 and V2, D1 and D2 you can replace as our common formula already you are having with you. So you can replace that and you can go ahead. Yes. So you can find out anything, whatever he is asking in the problem. Yes. Okay. So let's solve one small problem on this. First note down this note point. Okay. So let's solve one problem. Very small problem. A solid floats in a liquid. A solid floats in a liquid. Very easy problem. If you will understand, you can solve easily. At 20 degrees Celsius, at 20 degrees Celsius, with 75% of it immersed, of it immersed. When the liquid is heated, when the liquid is heated to 100 degrees Celsius, the same solid floats, the same solid floats with 80% of it immersed in a liquid, with 80% of it immersed in a. Calculate the coefficient of expansion of the liquid. Calculate coefficient of expansion of, and in bracket they have given here one thing. Keep it in mind. Assume that the volume of solid to be constant. Assume volume of solid to be constant. इसका मतलब क्या है? जो भी आप पानी में डाल रहे हो solid, its volume will not change. Means effect of temperature we have to neglect on the volume of the solid which you are immersing. So let me give you a hint. You can try yourself. I am giving hint only. You can try yourself. So see here, weight of floating object, weight of floating object is equal to buoyant force. है ना? This is from Archimedes principle. You might have learned in lower classes. So, weight of buoyant force on this floating object. So weight of floating object is equal to buoyant force. So what is here? See, case 1 I am writing because in the case 1, what he is doing, 75% of volume is immersed. And that time temperature is how much? 20 degrees Celsius. So देखो case 1, temperature is how much? 20 degrees Celsius. And V immersed is how much? V floating. 75% of it is immersed. है ना? So here V1 is equal to, you can say 75%. So I can say that V dash is equal to 75 by 100 into V. It is immersed, yes or not? So here weight will remain same. So therefore, can I write like this? Mg is equal to V dash into rho at 20 into G. So you are getting here 75 by 100 into V into rho at 20 into G. Yes. So this is what your Mg. This is your equation number 1 for the case 1. In next case, case 2 में हम क्या करेंगे इसको 80% है. You can see, and temperature is how much? 100 degrees Celsius. So temperature is 100 degrees Celsius. V dash is equal to 80 by 100 into V. So weight will not change. So mg is equal to here also V dash into rho at 100 into G. Double dash लेंगे इसको ताकि थोड़ा सा change आ जाए आपको. So this is your equation. I can write here 80 by 100 into V into rho or 100 into G. This is your what? M. Solve this equation number 2. Now what to do here? From equation 1 and 2, first equate. First note down this. Okay. And next, pause the video and note down this. Try to understand. Okay. And next, what you have to do? You got like this from equation 1 and 2. From 1 and 2, you can see, you see here, this left hand sides are same. So equate the right hand sides. When you are equating the right hand sides, what you are getting? You can see 75 by 100 into V20. V only V we will take. Yes. V into rho 20 into G is equal to, this side is what? 80 by 100. 80 by 100. Volume of object is same. Rho 100 into G. Isn't it right? You can check. So 75 by 100 V rho 20 G is equal to 80 by 100 V rho 100 into G. So then this G and this V will cancel here with this thing. So this 100 also will get cancelled. Yes or not? So this 100 and this 100 will get cancelled. And then you are getting something, or else you can cancel like this also. Choice is yours. This is something 3 by 4. This is how much? 4 by 5. So here you are getting 3 by 4. Rho 20 is equal to 4 by 5 rho 100. अब एक काम करो, जो रो 20 का वैल्यू है, रो 20 you know what is रो 20? Rho by 1 plus gamma into delta t is how much here? 20. And rho 100 कितना आएगा? Rho by 1 plus gamma into 100. Substitute these values here and then find out gamma. Gamma is equal to how much? Substitute these values here at the place of this and this and tell me the answer. Okay, so let's stop here. Solve this problem. Okay, bye. Enjoy the day.